to welcome everyone to the January meeting of the Fort Worth Astronomical Society. 2026 is starting off with a bang. We've had 2 consecutive nights where solar storms have really rattled the magnetosphere, or whatever it's called. Somebody can correct me on that. So if it weren't for the clouds, we'd probably be seeing or have the opportunity to see the aurora. We'll see what happens tonight. Plus, we were invited to participate in some training that the Kalamazoo Astronomical Society was putting on. They had their first lesson last Saturday, and it was fabulous. If anybody that has attended that will back me up. It went a little long, not 1, not 2, not 3 hours, but like 3 hours and 5 minutes. But they're not amateurs at doing this. They've been doing it for 20 years. Their lesson material shows it, and the presenter just has a passion for training. So if anyone's interested in signing up for lessons 2, 3, 4, and 5, send a note to info@fortworthastro.com, and I'll provide you the information so you can sign up. Or you can check your emails, because if you're in the e-group, I sent that back a little while ago. But I'd be more than happy to send it out again, because it was very good training material. For those people who are new to astronomy, as well as those people that have been at it for a while and may have forgotten some important details. Okay, let's go to the next slide. So I'd like to know if we have any visitors tonight. So the shy people don't have to respond, but those people who are visitors, I'd like you to raise your hand and be recognized. Hey, we've got a few. Yay. Let's pass the mic over. Can you take that? So welcome to the club meeting. If you wouldn't mind, just tell us your name, how you found us, and what you're interested in astronomy.
Am I introducing yourself? Oh.
Answer the question.
Right here.
I have my ear, so I have a hard time not hearing most, but anyway, we've been looking for some astronomical stuff for a long time and thinking about telescopes, but we didn't know anything about it, so we found your site, your website, and thought, well, this would be a good place to come. My name's Doug Spear. And
Okay, Doug, welcome. Right. And who's the young lady with you?
Leanne Summers.
Very good. Okay, so it's so good that you reached out to us now before buying your telescope, because we can give you all sorts of guidance as to what would be a good fit for you and what you want to get done. So once again, if you have any questions or want to follow up, send an email to info@fortworthastro.com, and we'll start a conversation. Okay.
I'm Sue Allen, and I was here in August of 2025, but I became a member tonight, and my partner is a member here, so I thought I would join him.
Well, fantastic. Welcome. And you joined the club tonight. That's nice. Way to go, Michael. Back to the right.
How's it going? Up there? Where? Any new members?
There you go.
Oh, there you go. Excuse me. You got it.
Hello, I'm Kelly. I just moved back to Texas from Washington State. Lived here 10 years ago, and can't see anything up there. So I'm excited to be back here. I became a member tonight, and I've had several scopes in the past, and just wanting to get another scope. And I saw that y'all had a site like 100 miles west of here.
Mm-hmm.
That I used to go to Fort Griffith.
Yep.
Out there. Is it Griffin or Griffith?
Griffin.
Griffin. I used to go out there and camp, and they'd let you stay inside the gate and camp in there.
Mm-hmm.
But I saw that y'all had a site, so just wanted to check that out and meet some new people.
Very good. Any other visitors tonight? All right, well, welcome. I'm glad you're here. Let's move on. Wrong page. There we go. Our last meeting was in November, and these are the folks that have joined since then. Any of the new members here tonight? Oh,
I'm here. This is Chip. I'm over Zoom.
oh, okay, you're online. Fantastic.
Yes. Yeah. Yeah. I received a telescope for my birthday back in November, and I thought it'd be a good idea to find the club. So I did some searches and found this, and happy to join. And looking forward to meeting folks at the star parties, and looking forward to learning how to use this darn thing.
Well, you've got the right attitude, and I'm sure we can help you become familiar with your scope to get the most out of it.
Excellent. Yeah, I had the first time I took it out, it was cold and miserable, and I didn't see a darn thing. Had it out again Saturday, managed to catch Jupiter and its 4 moons, saw some bands, saw Saturn, attempted the Orion Nebula, didn't see it, but I'm still calling the evening a success.
You've definitely made progress, so you're on your way.
Definitely.
Thank you, Chip. Good. Let's move on. Okay, so the nice thing about Fort Worth Astronomical Society, we've been around for a long time. We've made all the mistakes, and we're trying to improve upon that going forward. We currently have over 220 member accounts in terms of membership, and we have a wide range of experience. We have quite a few people who just do visual astronomy, and then we have a small group, a very active group of astrophotographers. And we're always willing to help. If you have any astronomy questions, whether it has to be what's in the night sky or about your equipment, so I think we can find the right person to help you. We're also a nonprofit organization, so if you have some extra cash around, you can make a donation of either cash or equipment. Let's go to the next slide. So our mission is to promote astronomy, and we've got a very good outreach program. And you'll see later on in the evening that we have a number of events that you can come out and participate in star parties. We talked about being interested in astronomy and helping people out. We try to get people to get out and observe as well as do research in astronomy. And then we haven't done this in a while, but we also have built telescopes, typically Dobbs, but we haven't done that in a while, but there's a small group of people that would like to see us pick that back up, so that's back on the table. Let's go to the next slide. In terms of our resources, we have our members handbook that kind of gives you the lay of the land of the club. We have a couple places that we can go and do observing. One is the Thompson Observatory in Keene, Texas. And then the well-kept secret, we have a dark sky site called Rising Star Observing Area. Last weekend, I took a new member out there, and he brought a guest, and they were both dumbfounded of how nice of a facility that was. And then we also have our online presence, and we have our Facebook account and our own website and a few others. Let's move on. So this is our top secret dark sky site out near Rising Star, Texas. Oops, I gave it away. So So it's roughly 5 acres of land, but there's 3.5 acres of green space. And on that green space, we've already constructed a number of pads. The pad that's on the far left is our Noble Observatory, and then the next one is McCatherine's, and 2 other people have leased pads. We have 3 pads that can be leased, and then the rest of the pads are club pads that can be occupied on a first-come, first-use basis. We have a number of buildings on site, astronomy buildings where we have most of the club equipment. The green building is a building where we have a composting toilet, and then the maintenance building is filled with, I don't want to say tools, but shovels, lawnmowers, and those things we use to maintain the facility. It's a nice site, Bortle 2, and when we were out there on Friday night last week, it was cold but dry, and I saw the arc of stars that were associated with Orion. I call it his bow, but I've heard it called the shield, and this is the first time that I've seen that out at Rising Star, so it was remarkable. It was a good viewing night, and it was also very cold, so that's why I left at 8 o'clock. And as I drove out, my car thermometer said the ambient temperature was 31 degrees, and my feet confirmed that. So, all right, let's move on. We do have a number of Dobbs that are available for use out there, and then we have some refractors. You can check those out. I know the 100 millimeter can fit on a Vixen mount. The other 2, I'm not sure, have mounts yet. We have several Schmidt-Cassegrains that are available. The 6, 8, and 9.5 are currently available. They have dovetails that you can use, and so is the Matcast 5-inch that's available. Move on. And these are some of our online presence at the club. If you're interested, check them out, and we'll go from there. No reason to go through them. We'd like to highlight the last one. This is our merch site where you can buy T-shirts, other shirts that have our emblem on it, and we now have hats and anything. What's that? Coffee cups? Yep, with our logo on it. So quite a few things. Next. So if you need additional information or info about the club, email info@fortworthastro.com. Or if you want to join, you can start the process by going to the Night Sky Network website, and you'll go through the process of signing up. Okay. So normally I'd have someone introduce Dan, but what we're going to do is jump ahead to the budget. Because we'd like to get the vote while we have all the members still here and none of them leave after the presentation. So I was going to turn to the treasurer to get a count to see if we had a quorum. But we would like to know from our friends who's monitoring Zoom, how many members do we have? We have 23 members? 23 members? Shazam. I think we're going to have a quorum. Okay. And 4 more on YouTube. Okay, so got the thumbs up, so we have a quorum. Fantastic. Great response. Okay. So the idea is that we're going to talk about the budget. We're going to discuss the budget, but I'd first like to have a motion to get the ball started. Very good. Oh, okay. So let's start the discussion. So I sent this out via Night Sky Network. They don't let us do attachments, so I gave you the link to where to go find it, but I wanted to go through each of the pages of the budget so you'd have a chance to ask questions, and we'll just start talking about the budget. So this is the summary page. The top line identifies where we think we're going to get our income from last year, for this year, typically based on last year's experience. And then our expenses are in the bottom. And so for the various club expenses, which cover everything from renting the room, paying for the parking spaces outside. Now they're charging us for that, and the club's covering that expense. Insurance, everything associated with managing the club, and maybe a little bit more. And then we have our committees that do spend money throughout the year. And then we have a new line item. Oh, that's an income. I'll get back to that in expenses. But expenses, we have our club expenses, then we have our membership committee, observing area committee, and the outreach committee that spend money to do the work of the club. And then we have the Novel Observatory Operations Committee. So going forward, there are some operational expenses. We wanted to get them in the budget, so we now have a line item. And one thing the board wanted to do was make sure that at the end of the year, we had some money left over, and so we have a surplus of $89.
Yeah.
All right, I'll take a round of applause. So that was very helpful. So the next slides are some, we're going into the details of how the money will be spent. So let's go to the next slide. Okay, so the first part is the income side of it. We get most of our income from new members as well as recurring members who sign up in the summertime. We do make money when we raffle the books off during these meetings. We do have some pad lease income. We couldn't figure out who would rent a pad, so we don't have any line items there. And then we also have donations that come to the club. For this year, we looked at our donations from 2025 and just took 25% of that. So we're not counting on all the donations we got from last year, but some of them. And then we do pay off the loan for what we have associated with the Rising Star facility. And so we do tap the Rising Star Development Fund for those funds to pay off the loan. So that's how we're handling that. And you'll see in the expense side, we have Rising Star loan repayment, and they're the same amounts, both coming into the budget and leaving the budget on an annual basis. And then in the bottom part is expenses. And this, I should say, this is the club spreadsheet that shows you the income sources and the expense sources. So you can see the various items that we have to keep the club operating. Some of the highlights is the club, through your dues, pays for your membership with the Astronomical League. So there are some payments we make during the year. We buy general liability insurance to cover the things that we own, the buildings, the equipment we have at Rising Star. And then we have the D&O insurance, and that's the directors and officers, thank you, insurance. And we've also covered people in leadership in the club, the chair people that we have, as well as those folks that interact with the public at star parties. As I was going through this the other day, I recognized that I had a typo, and that is when I was doing the honorariums, which is a new line item that we give to guest speakers. I left in the Christmas party, but I had changed it to holiday party, so there's two $250 bogeys there, but we really only wanted to have the holiday party. So we'll probably need to modify the budget tonight, because we just need to subtract the second $250. Any questions on club expenses or incomes?
Yes. I don't think we can vote on this unless it's accurate. So can you fix the spreadsheet now?
Well, the spreadsheet's been fixed at home. I can't fix what's in the screenshots.
Is there any cash on hand?
Cash on hand, you want to talk to that?
Yes, there is. Our current balance is probably 45,000 something.
Oh, 1 second.
You've got a slide after this?
Yeah, sorry about that. Yes, our current situation is very positive. Our balance is over $45,000. The last year's books have been closed. There is a internal audit that's taking place. The task force has been assigned. We're scheduled to meet next week, and we'll begin that process. Once that's finished, I will come back to you all with a report summarizing where we are, where the money was spent, where it came from, just like we did last year.
Thank you. Now, circling back to Bob's question about not being able to vote on this, I'm thinking we can if we just identify the problem and make the correction, unless you can explain why there'd be an issue. No, we would, yes, there is a problem here, so we will have to not vote on this. We don't have a second on this motion, so we shouldn't vote on this motion to approve it, but we'd have the numbers, and so we could vote on it, is my thought. Yes?
I make a motion that we can vote on the numbers as to be corrected. I second.
Well, we currently have a motion on the table, so we'll have to discharge that. And since we're in the discussion phase, I think it'd be prudent to go through and essentially find any other problem spots, and then we'll do it all together.
The secretary's making notes of all this, right?
She is.
So there's no problem with getting the corrections done until the record.
Hey, Bruce, this is Stephen Kennedy. I don't know if you can hear me, but as a point of order, a person can make a motion to amend the current motion. That would need to be seconded and voted on, and then you would vote on the underlying motion as amended.
Okay, very good. Yeah, so we're still working on the first motion. Right. All right. So,
You're saying that the document is correct.
no, the document that's on Groups IO has the same error in it.
Hang on. So the document that's been sent out to everybody is not correct.
That is correct.
Bruce, we just have to do what Stephen said. Modify the motion. And then we vote on the modified motion.
All right, so my point is, let's do that modification once by continuing to discuss the various slides, and then we'll entertain the second motion.
We already have one modification, which is to cross out the Christmas party line.
That's correct.
Save ourselves $250.
That's correct.
Right, but you haven't finished the rest of it,
Right,
right?
have not finished the discussion yet. Okay. Any other questions about the club expenses? All right, let's go to the next slide. Okay, so the membership, they do quite a bit of work for very little money. They only need just over $200, essentially for postage, letters and envelopes, and printing supplies. And that's how they keep the membership committee currently in operation. Last year, we had put in for the purchase of printers, but they decided it was better to let them use their own printers and supply their printing supplies instead of buying a club printer that would follow the membership chair person around. So that's why we have $205 for the membership committee. Any questions? Okay, next slide. Okay, so the Observing Area Committee, these are the folks, the committee that need to take care of Rising Star. So you'll see on the left-hand side and everything from restocking first aid kits to buying supplies for the composting toilet, down to maintaining the field, whether it be through our lawnmowers that they also need maintenance, or just things that need to be fixed, The observing area committees also have some tasks with maintaining the telescope, so we've added $100 for that task. There's another typo that I found. Miscellaneous signage is not actually signage, it's miscellaneous maintenance for that amount of $120. And those are the only two problems I found in it. Any questions on this? Okay, we have two more slides, and then we can talk about the underlying motion. This is the outreach committee. And then these are the items where they are purchasing business cards and brochures that are developed within the club to use as handouts at outreach events. And then they also have come up with this idea to have something that's branded with our either name or logo so kids can remember where they had their first telescope event, and they then may come back to the club in 20 years like the chairman of the outreach committee has done. So welcome back. As well as buying additional banners so we can have them distributed over the DFW, or not the DFW, our area, so we can promote the club brand when we're at star parties. Any questions on that? Yes, Michael?
The t-shirt, or the shirts, I'm guessing those are the ones, the embroidered ones that you talked about, Bob? Is that right?
Yes, it's like the one I'm wearing.
Right. Is it a one-time expense, or is that something that's going to be annual?
It's for folks in leadership positions, and that will change annually. But there is some carryover with people in leadership committees from year to year. So once we get the leadership committee outfitted, we'll just have a less expense going forward.
You said leadership and outreach leaders, right?
Well, no, the plan is to buy these embroidered shirts for outreach, yes, as well as the board and others. Okay.
Not just the board, but the
That is, oh yes, that's correct. Yeah, outreach, folks involved in outreach. And the reason for that is when we have these outreach activities, everybody's wearing their street clothes for the most part. And so if you have people that look as slick as this guy does tonight, thank you, then it'd be available for the public to say, oh, there's someone that they're representing the club, so they can come and ask questions or get information. All right. And then the Noble Observatory operations, we didn't know what it's going to cost the club to actually operate the observatory now that, can I say that? Now that it's operational? How would you like me to say that?
I'll go into some detail.
Okay, Bob's got a good presentation for us later today. But initially we only needed $18 for a SharpCat Pro license agreement to actually keep the observatory operational. But we also needed $50 for a membership of a person that we have a good relationship with who lives within 1.1 miles from the site. So if there's a big thunderstorm and we think we need him to go check on the field, he'll go over there. If there's something that he can do and save us a trip, he will make those adjustments.
And he's a great guy, and he's got a great tool shop.
Right. He's a ham operator. We've seen a lot of email and e-groups about that. He has an electrical engineer background, and he's also a board member of the Cross Plains Library. That's how I got to know him. Solid guy. And so what we're doing is we're buying a membership in the Fort Worth Astronomical Society. So we're paying ourselves to get him to be a member so we can then allow him to get the codes to access the facility. The bylaws that we have didn't consider that type of arrangement. So this is how we're making it work. So it works. Any other questions about this? Okay, so I've identified 2 problems with this budget, and what do you want to do about it?
What are the 2 problems? What are the 2 problems?
Oh, one's a typo, it's not miscellaneous signage, it's miscellaneous maintenance. And the other one is I added $250 to the budget that needed to be removed from the budget.
Mr. President, I'd like to make a motion to amend the current motion on the table to delete the line item, which is a duplicate for $250, and to adjust the wording of your chart to delete the word signage and then put maintenance. That's my motion.
Very good, thank you. Okay, so Krish Ashford has seconded. Is there a discussion on that? Okay, so all those in favor of the motion, raise your hand so we can count. What's online? What do we have online? Can they lower their hands? Yeah, thank you. And so we're counting the folks online. So one moment, please.
I don't know how to do mine, but I approve it.
Oh,
Sorry.
This is Jim Pewitz. I approve. I cannot figure out how to raise my hand.
thank you, Jim.
And David Ruiz as well. Sorry.
Oh, okay, so now who's opposed to the amendment? So no one here, anybody online? No, so what's the count? 42 approved and no objected. Okay, so the modifications have been accepted and approved. So should we call the question?
I do have that question. Last year, when you started talking about, in the last meeting, you talked about the budget, there was discussion about whether to include an estimate for 1687. Did the board decide just to go with 0, which I'm just asking, because
Okay.
there was some discussion about.
Okay, so, right. So here's how I see it working. So any funds that come from 1687 all go into the Rising Star Development Fund. Okay?
I'm listening.
Okay, and that fund contains how much money right now? $2,200. So what we're doing is we're taking out of that fund the amount of money we need to cover the payment of the fund. So we're required to make 2 payments. Payment of the loan.
You said bond.
Oh, yeah, but we're tapping the fund to get that money to pay it, the loan. And so no star parties come involved in this. We're just dealing with the fund. And the fund is flush, so we have monies to cover the loan payments. Can we go back to the second page of keep going to the club, just to show you how this works. One more. Okay, so we're pulling out of the development fund the money we need for the principal and interest in the spring and the principal in the fall. Any star party money goes into the fund regardless of what the budget is.
The 1687 money, the original intent was to be used to pay off the loan.
Yes.
Period.
Yes. And here is the loan payment item. And that's what we're using, that's what it shows up in the budget. we tap the development fund to pay off the loan.
The original intent was to pay off, use the money to pay off the loan, not anything else.
And that's, isn't that what it's doing? The Star Parties fund the development fund. That's where those monies go. And then out of that development fund, we ask for the same amount of money that we need to pay principal and interest. So we're not,
It sounds to me that we're using the 1687 money for more than paying the loan.
okay, if you agree that we're paying the loan, what other things are we paying for? So we can clear that up.
Bob, every dollar of 1687 money is gone towards loan repayment. And the board, when you were president, we approved that pathway for payment. So you are correct. Every dollar of 1687 money pays off the loan until the loan's paid off.
Okay.
Yeah, we discussed that the other day on the last board. I think that was this.
Okay, no, yeah, make sure everyone understand. So the fund continues to grow.
Okay.
Yeah, and these are just minimum loan payments.
Okay, I'm with you.
Okay, right,
I think that was 2024 December, so that the board.
right. And just to clarify one thing, before we couldn't predict how many Star Parties were, and we went down the wrong path by listing Star Parties, so we just had a blank. And then we were penalizing the budget by pulling money out of that. So that's why we have it this way. Great question, great question. Okay, so we have,
One other thing I wanted to point out, this represents the minimum payment.
yes,
And when we have extra 1687 money, we pay extra.
Yeah, and that's fine.
So
Yeah.
it does all go that way.
okay. Okay, so what's the next step? Is it called a question?
We voted on the motion, we haven't voted on we voted on the amendment,
Yes,
we haven't voted on the motion.
all right. So then I just ask for a show of hands, is that where we're at? Do we need a,
Did someone second the motion already?
Robin did too.
The vote was on the amended motion because
Yeah, the amended motion is, voted on.
Well, was the amended motion my motion?
no, it was Stephen Kennedy. Stephen Kennedy made
So-
a modified motion.
Wait, so we have three motions up, we have
No, we
the
had
original
two.
motion, my motion, which is amended.
Okay, so no one seconded your motion.
Your motion was superseded by Stephen's motion.
Which is the same,
Which is basically the same motion.
no, his was, we can't move forward.
But like you said, nobody seconded it.
So what happens, it just dies?
I think so.
Anybody want to challenge me on that?
The motion fails for lack of a second, and therefore you should call for a vote on the underlying motion as previously amended.
We got the underlying motion.
To approve and no opposed.
Right, that's correct. So now do I call let's have the vote for the initial motion.
No, the initial motion was modified, and we voted on the modified motion which passed. So the budget,
Oh, I'm sorry, I see what you're saying now.
yeah, we're done.
Okay.
The budget is approved.
I disagree.
Oh,
We voted on the motion to strike the one line item and modify the other. That's what we voted on. That's what I voted on.
right. That's what my understanding was too. So now we have the first motion that Constantine gave.
But Stephen made the motion.
Right, so what we are now voting on is Constantine's motion, which has been amended to delete the $250 duplicate item and to correct the wording to change signage to maintenance. That is what we are now voting on, and if we vote on that, then we're good to go.
We voted on that, but we need to, essentially voting on the motion as amended.
Right. So, all right, so let's have the vote on the motion as amended. Okay, raise your hand if you're in favor. To approve the budget as amended. $15? Okay. Okay. $15 online. And so, can you tell us the vote, Madam Secretary?
47-4, and we need to vote for those opposed.
Okay, those opposed, raise your hand. Anybody online? That said no? Okay. So can you remind me, Madam Secretary, what the vote was?
I'm sorry?
What the vote was?
47 approved.
47 approved and no objections.
Was there any online?
We checked, and there was not.
There was no one here that opposed, so it was 47 approved, so.
Okay, very good. So I've taken up too much of Dan's time. Yeah, so walk this way. So Dan has a good presentation on the lifespan of a star and how you classify that.
He thinks it's a good presentation. Yes, the Hertzsprung-Russell diagram. How many of you have ever looked at this thing? Oh, I have to stand. I've got the dot right there, right? Okay. Next slide. This is something that's basic that most astronomers are very familiar with. How many of you guys have seen this? Okay. How many of you know where it comes from? Oh, that's why I'm here. Okay. This defines what's called the main sequence, and this is the result of 450 years of study of stars, and we're going to go over that. So we're going to cover 450 years in the next, 35, 40 minutes, we hope. So next slide. This is going to go back to a guy who a long time ago, back in the early 1600s, late 1500s, decided that he was going to measure something called parallax. Does everybody know what parallax is? Some of you do. We're going to do an experiment in a minute here. Next slide. It's the difference of, or change in the apparent position of an object as seen from two different points. Okay, next slide. In astronomy, it's used primarily when you observe stars from two different sides of the orbit of the Earth. So you get a baseline and you look at the star and you check to see how it moves. So we're going to do an experiment here real quick. Next slide. Oh, this is a diagram of what it is. So you have a baseline, which is the distance from the sun, and as the Earth goes around, you measure how something moves across a background that you hope is stable, that doesn't itself move. So the experiment goes this way. Next slide. I want you to take your right hand and stick your thumb out and cover the red dot and close your left eye. Okay, everybody doing that? Okay, now close your right eye and open your left eye, and what happened to the dot, to your thumb? It moves. Well, and if you remember your trigonometry, and I'm sure all of you do, you could calculate, based on the distance between your eyeballs, how far away your thumb is. Okay? Isn't that great? I mean, that's a nice, handy thing to use. So that's what parallax is. That's how it's used in astronomy. Next. A guy who was obsessed with it was Tycho Brahe. Now, you may have heard of him. He was a Danish nobleman who lived from 1546 to 1601. He was rather eccentric. You may have heard stories about he had a somewhat volatile temper. He lost his nose in a duel and wore a gold and silver nose for the rest of his life. And when they dug up his body to check it out back in, I think it was 2010, they dug him up. And they found that his skull was in fact blue, which means somebody cheated him because the nose was copper, not gold. So anyway, he was obsessed with taking measurements to a degree that nobody really had done that before in Europe. Next slide. The King of Denmark, he was a nobleman, so he was involved with the King of Denmark, and the king decided to give him an island where he could just do whatever he wanted to. He could have a good time building his stuff, and he did. He saw an eclipse, or not an eclipse, a supernova. There was a supernova in 1572, and he did some observations on it. Next slide. He spent 15 years building his own instruments and making measurements. Next. He built quadrants, some of which were up to 4 or 5 feet in diameter. A quadrant is a sextant, but it's 90 degrees as opposed to 60. Eventually, he fell out with the new Danish king, so he had to move to Prague, and he lived in Prague for the last 4 years, and he picked up an assistant by the name of Kepler. You may have heard of him as well. And Kepler, of course, used his information, Brahe's information, to develop his 3 laws of planetary motion. But Brahe was obsessed with parallax, and he could measure down to about 1 arc second of, 1 arc minute of parallax for stars. And he could not detect any parallax in any stars. So he concluded that the universe actually was a solid dome out there, a solid firmament, or whatever you wanted to call it. He concluded that Copernicus was wrong. And there's a whole book on how he came up with this. I'm not going to go into the details. But his measurements were incredibly precise. So next. Based on his observations, he came to the conclusion that stars had to be at least 700 times as far away as Saturn, and he just couldn't comprehend that stars could be that far away. And so that's why he rejected the Copernican model for the solar system. Next. So to give you an idea of what an arc minute and an arc second is, now again, he could get down to 1 arc minute. So, you know, the sky is 360 degrees across all the way around. 1 arc minute is a 60th of a degree, and 1 arc second is a 60th of a minute. So we're talking very small amounts, very small distances. To put that in perspective, if you look at the next slide here, the moon is about half a degree, okay? It's about 30 arc minutes across. Next. Copernicus, ironically, the Copernicus crater is almost exactly 1 arc minute in diameter. So next time you're looking at the moon, see if you can pick out the Copernicus crater on the surface of the moon, and that'll give you an idea of what 1 arc minute is. So he could measure the positions of the planets down to about 1 arc minute. It usually was about 2, but occasionally he had numbers down to about 1. A 1 arc second would be that little crater, that little mountain in the middle of the Copernicus crater. So next time you're looking at the moon, think of that as the things that have to be measured. Why am I pointing this out? The closest star is well beyond what 1 arc second would be. We'll get to that measurement later. It's actually about 3/4 of a second. But that's the closest star. Put in perspective, let's look at our planets here, some examples. Jupiter is 50 arc seconds across at opposition. So right now, if you go to look at Jupiter, that's about 50 arc seconds, not even an arc minute. Mars is 25 at opposition. Saturn is 20. Uranus is 4. Neptune is 2. So we did at the star party at Dinosaur Valley. A number of us looked out and we could find Neptune, and that's 2 arc seconds across. So if you're trying to measure a parallax of a star, that's less than half the distance of the diameter of Neptune. So if you've ever found Neptune, now you're talking about what the distance is, what the size is. Oddly enough, the International Space Station is actually up to 63 arc seconds across. So from the surface of the Earth, if it's passing right overhead, it's actually larger than Jupiter. Okay, once you have parallax down, you need astronomical units, because you need to know what that baseline is. And that's something that's been an argument for 2,500 years. Greek astronomers were coming up with this stuff where they were trying to come up to determine how far away the sun was. And you need to know the astronomical unit, the distance between Earth and sun, as a baseline. They were initially based on Earth radii. Now, nobody knew exactly how big the Earth was. There were good guesstimates. But they did calculate it based on the radius of the Earth. Next. By Brahe's time, the general consensus of the size of the radius of the Earth was between 3,500 and 4,500 miles. Okay, some people would come up with better numbers, but that's roughly where they fell into. Columbus had it much smaller. That's why he thought he could sail across the Atlantic Ocean to Asia. But he was using numbers from another ancient astronomer. Brahe used Ptolemy's numbers in which it came up to about 1,210 radii, which translates to about 4,700 or 4,700,000 miles. So that's what Brahe was looking at. Now again, this is in a time when people were riding horses. So the concept of a 4 million mile distance had to be mind-blowing for Brahe, and thinking about how much further that was with the planets, what's going on in his mind on that. It's really quite mind-blowing for somebody back in 1590. Diameter of the Earth was another thing that came in as an issue. As early as 240 BC, many of you have probably heard about the Greek mathematicians who did some calculations. One guy came up with 250 stadia. The question becomes, how long is a stadia? And there's a big argument on that among among archaeologists. The number ranges from 160 meters to 210 meters. So depending upon which number you pick, that gives you an idea of how big the Earth is. This guy's Eratosthenes measurements, our best guesstimate is that's between 87 and 9,100 miles, which is a pretty good guess for the diameter of the Earth back in 250 BC. Next. Posidonius came up with a slightly different number. He actually, the first guy used, you may have seen something at some point where the astronomer looked at a vertical pillar in Alexandria, Egypt, and said, oh, there's a 7.5 degree shadow, and at this other place on the Tropic of Cancer, on the summer solstice, there's 0. The sun's pointing straight down. That's where he came up with that number. He calculated the distance between the two and did that. Posidonius came up with Canopus. He could just barely see Canopus on the horizon when he was in Rhodes, and when he went to Alexandria, it was 7.5 degrees above the horizon. And that's where he came up with his number. Now, he didn't know about how the air bent observations. So He kind of stumbled into that number, which is pretty close. But that's one of the things that he considered. Next. Strabo decided that Posidonius' numbers were wrong as far as the length of stadia, but that's the number that fell into Ptolemy's geography that was still used 1,300 years later when Brahe was doing his stuff. Next. So after Brahe died, and one story about him dying is he was at a party being held by a nobleman in Prague, and he refused to get up and go to the bathroom because it would have been an insult. And he wound up bursting his bladder. That may not be the truth, who knows, but that gives you an idea. People believed it because that's the type of guy Brahe was. As time went on in the 1600s, people were looking for the parallax. They were trying to determine how far away stars were, and by 1688, Robert Hooke, 1668, attempted to measure it. He built a micrometer, which he was the first accurate micrometer, but it still wasn't good enough. Next would be all the repeated attempts failed because we're dealing with measurements that are below 1 arc second. And again, that meant they understood how far things were. That meant that these stars were hugely distant away, and it just was, again, mind-blowing. By the mid-1800s, 18th century, though, they came up with this thing. This is called a heliometer. And what it is it's two mirrors that attach to the end of a telescope, and you can adjust the mirrors, much like a sextant. You move one mirror until the two images are on top of each other. So you look at one star in the bottom mirror, and you look at another star in the top mirror, and you adjust the dial, one mirror, until you figure out what its angular distance is. And they were using this to calculate how far away, and they still couldn't come up with the numbers. It wasn't until the 1830s that somebody was actually able to measure a parallax. That was, one gentleman claimed that it was 4 arc seconds. Vega was 4 arc seconds parallax, and that was not nearly correct. Vega's actually a 0.13. A German astronomer finally measured a nearby star at 11 light years away in 1838. And that was the first time somebody could absolutely, positively be sure something was outside the solar system. Okay. Then others started measuring. There were a couple of other successful measurements. Alpha Centauri was measured at 4.3 light years away. It was published. To give you an idea, the guy who came up with this number could not believe it was 4.3 light years away, and that's why he didn't publish for 6 years. And it wasn't until after the Bessel published his numbers that he released his data. So it was, it gives you an idea that this, again, is mind-blowing at that point in time. Vega was finally measured accurately, or relatively accurately, in 1843. We'll come back to Vega a couple of times later. And other stars started to be measured down the road. So we've got parallax. We know how far away stars are. We can figure out how far away stars are. And there are ongoing measurements with satellite technology. They're able to measure accurately to within about 500 parsecs, or about 1,500 light years. So those are relatively accurate measurements now, using a number of satellites to do that. In fact, the New Horizon mission did some parallax work, and they've got photographs of how one of the stars that it was taking pictures of is clearly different from Earth and where it took the picture in 2016. So, next. So, now that you're able to figure out how far away stars are, the next thing that winds up happening are spectrographs. People started being able to run stars through spectrums. They had to come up with a way to record that information, and they started using just flat glass plates for photographs. Because you couldn't, how could you record a spectrum when you didn't really have anything to absolutely measure it with before you had photography? So photography opened the door for doing that. Next. A gentleman by the name of, husband and wife actually, William Huggins and his wife Margaret began to use, in 1860, photographs. And that gives you an idea of how far back they were doing it. And they came up with a couple of things that surprised them. Stars and the sun were made of the same stuff. When you looked at a stellar spectrograph and a solar spectrograph, they were similar. So that means those points of light out there were the same thing like our sun. Next. They also recognized that there were different spectral lines for different types of stars. So if you're looking at Betelgeuse, yeah, it's red, but its spectral line is going to be different than Rigel or some of the other stars. Next. Finally, they started putting them on plates, and I think I've got an example of that here. William and Margaret Huggins did the first photographs. So now you started getting absolute information on it that you could permanently go back and look at. Before then, it was all, you take a look and you draw something and hopefully you're right. Here's an example of early spectrum of stars. Now, this picture was taken in 1890, but that's what they were dealing with. They would set up a grid. Again, I just blanked on what you call it, but they could feed the light through, and you would be able to measure what the particular spectrum of stars was. Next. So when they started measuring the different spectrum of stars, they noticed that there were differences. And they're like, well, what do these differences mean? They decided initially to classify them, and the first set of classifications came out by an Italian priest who grouped stars by the colors and absorption lines. And he grouped them into essentially 5 colors and other, or 4 colors and other. That was his group. He had them as Roman numerals, group 1 through 5. But at Harvard, around a little bit after this, people started getting a little bit more detailed on that. Marianne Draper, and we'll go into a little bit more of her later, started going into some details on this, and she broke up the categories into A through O. And that's where we get the familiar ones that we have now. So she had A through D was the white color. Those had the strongest hydrogen lines. E through L were yellowish, and they would have not quite as strong hydrogen lines, but they would also have other stuff in them as well, and on down. Now, O doesn't have any hydrogen lines, and we'll get to why that is in a bit, but that's why O is down at the bottom there. There's no hydrogen lines. Draper was one of a group of women called the Harvard Computers. And this is a group of people that really astronomers should be blessing and thankful that these guys came, or these ladies came out, because they're all women. They were all employees of Harvard Observatory. They came in through various ways. Beginning in the 1890s, they started working as the technical people. They didn't do the observations, they analyzed the observations. And they did an amazing job on it. So you have Mary Ann Draper. She was the wife of an astronomer at Harvard, an amateur astronomer. He was putting together a catalog of 10,000 stars in like 1870. And he wound up dying in 1882. He had a lot of money, and she helped fund the Mount Wilson Observatory. Some of her money went to that. Wilhelmina Fleming, she was a maid who worked for the head of the observatory at Harvard. And she started categorizing stars by hydrogen lines. She categorized tens of thousands of stars. She was responsible for all of the photographs that were taken by the Harvard Observatory. The estimate at the time of her retirement was 120 tons of photographic plates. Okay? That's what she went through in her career. She retired in the 1930s. But she started as a maid, for crying out loud, and she's doing this stuff. Antonio Mari revised the classifications, and her work is the basis for the current categories of stellar classifications. Some of the others. Anna Winlock determined the positions of literally thousands of stars. I've seen one number that said she calculated the position of over 300,000 stars that are in the German catalog there. Next. Henrietta Leavitt, she developed the method to measure magnitude using photographic plates. Okay, so now you didn't have to just kind of look and say, well, that looks like a magnitude 3 star. No, she actually came down with the absolute way of doing that. She also is the one who discovered that Cepheid variables' brightness was dependent on their period. So when you see what Hubble did, the astronomer, not the telescope, but the astronomer in the 1920s, measuring how far away something was based on the Cepheid variables, it was her work that was the foundation for that. And it's still used as a basic standard candle for nearby stars. And then Anna Jump Cannon is the one who actually broke the classification down into our current normal classification, where she determined that the spectrum was dependent upon the surface temperature of the stars, and determined that O is actually the brightest. O is this highest surface temperature. It's so high that there are no electrons in the surface. So the hydrogen atoms don't have any electrons, so they're not bouncing up and down, so there's no absorption lines. So that's why there's no hydrogen lines for O-type stars. And then it works down OBA, FG, KM. So this is the current definitions of stars, of types. There are some unusual ones. The Wolf Rayet are very strange. There's a group of them, believe it or not, the surface temperature starts at about 25,000 degrees, and this actually is a little bit off on the size. They guesstimate some of them are up to 300 solar masses, which is an incredible, think about 300 solar masses for a star. And amazingly, there is in the Large Magellanic Cloud an open cluster that has about half a dozen of these type stars, all within 2 parsecs of each other, all within 6 light years. So, I mean, I can't imagine what that thing's going to be like when they finally blow, because, I mean, it's going to be bright. But yeah, that's the, anyway, as we go down, you have O. Some of those stars get up to 30,000 degrees or higher. There are stars that have been measured, they estimate, at upwards of 120,000 degrees, but surface temperature. But anyway, O-type typically have a temperature of about 30,000. And then as we work down, O, B, A, F, G, K, M, we get down to the M. Now along this side here, you see the percentage of the main sequence. The O-type stars are extremely rare, but we do have a few of them that we can see regularly. 2 of the stars in Orion's belt, the 2 outside ones, are O-type. Now they're both like 1,500 light years away, to give you an idea of how bright those are, okay? And they're still fairly bright stars. A, Sirius is an A-type star. And then as you work down, F is just a little bit bigger than our sun. Our sun is a G-type star. And it continues down. So this is just a kind of a snapshot of what the sizes are. Now M, excuse me, there's some other traces that have been added more recently, categories, C, S, L, as telescopes have gotten better, and you're able to get measurements all the way down to very, very low, like, you know, we're talking 20, 22 magnitude stars. They need to be able to, they've been able to find some of these stars at these lower categories. M typically is the lowest. You'll see there that they are tiny stars, and they are just barely big enough to kick off hydrogen burning. And they'll last a long time. I'll go into a little bit more of that in a minute here. But this is a good example of the current definitions of spectral types. Go on to the next. So once you know how bright a star is and you know how far away it is, you can figure out absolute magnitude. And an absolute magnitude is the measure of luminosity, of absolute luminosity. How bright is that thing going to be if it's a set distance away? The baseline is 10 parsecs, or 32.6 light years. So you'll see, if you look at something in like Wikipedia or any place else where it looks at the stars, it'll say a magnitude, and then it'll have absolute magnitude. And it's calculated back as to how bright would that be if that was 10 light years away. Our sun is about 4.3, has a 4.3 absolute magnitude. So it's a fairly dim star. You'd barely notice it if it was 32 light years away. Some of these O-type stars have a magnitude that's almost a full moon at the distance of 10 light years. So you can give an idea. Now, the magnitude, every magnitude is 2.5 times dimmer if you're going up. Okay, so it's 40% of it. So as you're going up, they get dimmer. As you go down, a negative number is a brighter star. The baseline was decided that it's going to be 100 times brighter. Magnitude 6 is 100 times as bright, or 1% as bright as a magnitude 0. And magnitude 0 is Vega. Vega, the star that we see in the summer as part of the summer triangle, that is by definition the 0 magnitude. So everything is based off of that as a magnitude. And it happens to be about 28 light years away, so it's actually, absolute magnitude's almost the same thing. Observed magnitude is affected by the square of the distance. So if you're twice as far away, it's a quarter as bright. And so if you work it the other way, you can figure out how, if something is a given magnitude and you pull it in, you're going to know how bright it's going to wind up being. There's formulas. I wasn't going to bore you with that or make you glaze over. I've sat through some of those lectures too. So weren't going to do that. But once the distance is known, the absolute magnitude can be calculated. So now you can take the absolute magnitude, and you can take the surface temperature, and you can then start plotting it on a graph. Now, when they originally did this, I'm sure back in 1895, when they started doing it, this is what they expected. Surface temperature along the bottom, and luminosity going up the y-axis, and they did not expect anything that was going to be nice and neat and a nice, pretty picture. They figured that it was just kind of like a random scatter shot of these measurements. However, that's not what wound up happening. You can go into the next one. This is what wound up happening. They discovered that stars of a particular magnitude, typical of a particular surface temperature, have a particular luminosity related to that surface temperature. That, in turn, is related to the mass of the star. So the smaller the star, the cooler it is, and the longer it lives. So our sun is guesstimated to last, what, maybe 10 billion years total when it's done. We're about halfway through, maybe. Not that anybody was around to check when it started, but that's the best guess. So as the stars get hotter, they get brighter, but that means that they burn faster. And if they burn faster, that also means that they're going to die earlier. And so as they plotted these out, they discovered that, in fact, the surface temperature and the absolute magnitude is almost perfect indicator of what is going to happen to this star in the future. So you're going to start off with the M-type down here in the lower right-hand corner, and it's going to continue to go up through to the O-type in the upper left. There are supergiants, which are kind of fall out, but they typically are in the process of, well, they're huge stars by mass, or they're in the process of burning everything out. Because what will happen with the star as it gets older is the core is going to collapse when there's no more hydrogen to burn. Now, in one of these small stars, that's going to take forever. It's going to be billions and billions of years for them to actually burn out of their hydrogen. And when they collapse, they're not going to collapse enough to cause the next set of burning to start, which would be helium burning. Now, you've all gone through this at some point in time when you think about why do you have like Betelgeuse and Antares being so cool, but also being so bright? Well, think of it as 100 10-watt light bulbs are going to be brighter than one 100-watt light bulb, right? If you're looking from a distance. So you just have a huge surface area. Well, why do they have a huge surface area? Their core is burning at a much hotter temperature, and it's pushing the outer layers of the atmosphere out. And as those layers of the atmosphere go out, they cool. How many of you have taken one of those little air guns that you use to clean off your keyboard, and it gets cold as you're spraying? Why? Because as pressure drops, temperature drops. Conversely, pressure as it goes up, it goes up, the temperature goes up. So in the center of these stars, the gravity is pulled in so much that they've gotten hotter and they can start burning hydrogen. They can start taking, or helium, and they can start taking helium atoms and slamming them into each other, and they get energy from that. And that continues all the way up to iron, and I'm not going to go through the whole list. That's probably something for another time. But essentially, stars like Betelgeuse and Antares and some of these others are in that situation where they are, the center has gotten so hot that the outer atmosphere has been pushed out. And so it's cooled down. At some point, when they burn out all of their helium, it's going to collapse again, and the star will collapse a bit, and it'll get hotter, and it'll again expand. Some of these are bouncing back and forth. Polaris, for example, bounces about half a magnitude over a 5-day period. And the assumption is it gets hot, and then it cools down a little bit, so it shrinks, and that's why it goes down in color. But as it shrinks, the temperature goes up, and so it expands again. So it's these kind of like a bouncing ball that's happening. As you go up the scale, you wind up with brighter stars that are going to take less time. They're going to be around for less time. As I said, our sun, maybe 10 billion years. You get to Sirius, which is a A-class star, and that would wind up, estimates of burning out is maybe 1 billion years. You get to these really hot stars, really don't know how long they're going to be because we haven't seen any of them blow up yet. I mentioned this globular cluster, or not globular, open cluster in the Large Magellanic Cloud. These stars that are there, massive. A luminosity, 10,000, actually beyond that. There's some of them that they estimate could be 20 or 30,000 times as bright as the sun, maybe even more. And they're going to burn out in an incredibly short period of time. And I'd really love to, I looked for some stuff as to why this would form in such a place. It's really strange that you have half a dozen of these massive stars all within an extremely close distance. But you do, and as I said, it's going to be quite a show once it winds up blowing up. So this is what the main sequence is, and this is how it's been categorized. White dwarfs are hot, but not very luminescent. They're the remnants stars. They're what's left over after Betelgeuse, maybe that doesn't blow up, maybe it just kind of pushes all the outer layers of the atmosphere away, and the core collapses, but it doesn't get hot enough to start burning at the next level. So that's the white dwarfs. Next slide. So this is what the HR diagram brings to you. Brightness, color, and mass and age are all tied together. So if you can get the spectrum of a star, you know a huge amount of information about that particular star. Knowing the place in the diagram helps you calculate the mass, and then it helps you calculate its luminosity and its potential age. So that's what the HR diagram is. It's used all the time. It's a handy little tool to have, and that's it. Any questions? Yes, sir. Yeah.
How do you view Polaris and Sigma Octantis?
Excuse me?
Polaris and Sigma Octantis down in the south, the southern hole?
Okay.
How do you parallax that if you can't actually?
Oh, well, you're still on either side of the sun.
Yeah, but is it always?
It's always directly above, but you're looking at the stars beyond it. Okay? You're measuring Polaris compared to the stars beyond it, or the galaxies if you get a good enough telescope.
It's on the celestial plane, straight above.
Right.
So as we move around the sun.
You're measuring the stars in the arc above Polaris, behind Polaris.
Okay.
And as I said, they've got satellites now that, I can't remember the name of the one star, the one satellite that they've got using it, but that they are trying to measure everything within about 1,500 light years. Hipparchus, that's correct, yes, thank you. I knew it was named after some Greek astronomer. Questions? I see somebody in the back there? No? Okay.
I don't see any.
All right. Well, thank you very much. I appreciate your time.
Thank you.
Hey. Here come the lights. Put your sunglasses on. Whew.
Okay, so let's assume it's 8:30 now. Let's take a break, 10-minute break, and then reconvene with the raffle here at 8:40. Oh, it's not that she buys 100 tickets? There you go. Okay, and we'll speed this up and call the next number, 155078. 078. Hey, all right. We also have a compass, glow in the dark. I don't know if it has uranium in it or not, but
Help you find the North Star.
that'll help, yeah. Thank you.
Joe Allen was my cousin's roommate in college.
Really? Wow. There you got it. We have a happy customer. Next number, 155097. 097. Okay. Very good. Thank you. And so my job is to haul these books to and from the meeting room, so I'll have 3 more, so I don't have as much weight. 155089. 089. Okay, Charlie. Thank you. Trustworthy. There you go. Okay. 155075. That's correct. I thought I would check. And then our last number for tonight, 155068. 068. Okay, Ted? All right. So, what's the next slide on the agenda? Do we actually have a, what's in the sky? Oh,
Yes.
thank you. So, Bill, it's about your time. I'm going to turn the lights off.
All right.
Down.
Thank you.
Sorry about that.
Okay. All right. Can everybody hear me okay? Can y'all hear? Yeah? Okay, cool. So, hang on a second. So, greetings from sunny Tampa, Florida, where it's actually colder than Fort Worth is right now. Okay, so what we got in the sky? Tonight through February 17th, the next meeting, and definitely wanted to feature on the cover of this one. It's fantastic collaborative project by Chris Ashford, Glenn Frazier, Stephen Kennedy, Jennifer McCatherine, Jim Potts, Robert Circus, and David Stadler, all contributing tons and tons of data. You've probably seen it in the group IO postings. And there was a vote, and Jim Potts' effort on processing the data won the day with, I think, Jim McCatherine coming in second. but just a beautiful, beautiful capture of Helix Nebula, Eye of God, Eye of Sauron, whatever you want to call it. Bright comets this month. So we've got two. 2024 E1. It's in microscopium. It is brightening. Right now, it's about magnitude 7.9. Then there's 24 P, which is in Boetis right now at magnitude 8.4. And I think it was 2024 E1 that's actually supposed to have been brighter. They're not sure. I think it's either the 24P or it's the E1 there that's not it's speculated to perhaps not be as bright as it was hoped to be. But we've got other comets that are coming up besides these two that are going to start appearing as bright in our skies. By the way, this is Bruce Campbell's image of 2025 R2. February's full moon's on Sunday, February 1st. This is a shot of the moon by Robert Cargill here. And the thing we've all been waiting for, Artemis 2. This is the first manned launch to the moon since 1972. The first launch window starts on Friday, February 6th. This is actually the calendar for that. So you've got launch windows 6, 7, 8, and then 10 and 11, and then into March and into April, showing the days when a launch is possible and even the times that they are as far as the size of the window and the time of the window. So a handy little thing to keep here. I wish I was going to be in Florida when this was happening. I understand that you may not be able to see the rocket, but you can certainly see the launch from Tampa. Let's see. So this is the Artemis. This is the mission plan here. So it's gonna launch from Cape Canaveral. We're gonna get orbit the Earth, and then it's gonna do an orbit around the moon. So this is a manned. You know, Artemis 1 was unmanned. This one has the crew on it. Nobody's gonna land on the moon, but it's gonna go and it's gonna take a pass around the moon and come back. It's about 8 days there. 4 days there and 4 days back, with basically 1 day going around the Earth before it heads to the moon. February's new moon is Tuesday, February 17th. This is Patrick McMahon's beautiful sliver of a moon here. So we have an annular solar eclipse. It's closer to apogee than perigee. I think I got that right. Which actually only eclipses the middle of the sun. The moon's further. Yep, that's right. Moon's further away from us than a total eclipse. So we get the whole ring of fire action. That's on Tuesday, February 17th. This is actually a picture, Christian Sinzik's picture from the 2023 annular eclipse. And if you just happen to find yourself at Murney Station, or perhaps even Concordia Station in sunny Antarctica, you'll be able to see it with your own eyes. My research indicates that there's about maybe 50 to 75 people that are stationed, scientists and such that are stationed down there right now that'll get to see it. So good luck. And then there's this guy. I always like to show the I always like to show the other annular eclipses. So that was Phobos and Deimos from 2019 on Mars, of course. And there's not a whole lot that goes on in January normally in the sky when it comes to just like regular events and stuff. By the way, bumping back to the annular eclipse here, you know how it always is, or almost always is that if you've got one eclipse, you've got another. So with the annular solar eclipse, we're going to have a lunar eclipse, and that's going to be something that happens later on. Stay tuned to next month's um, presentation on that. So this month's constellation is Carina the Keel. So we're talking about the keel of the Argo Navis, along with let me see, Vela and Puppis. And this was Argo Navis was the largest constellation back when Ptolemy put it in his Almagest in the 2nd century, and it was a very unwieldy constellation. It was troublesome for star charts. It was too much. Um, Nicholas Louis de La Salle actually broke up the boat in 1755, split it up into what he unofficially was the constellations that I named, including Carina. And then the International Astronomical Union formalized Carina and its two other boat parts in 1930. So there's 11 stars in this constellation with known planets. There's 6 named stars, including Canopus, which we just heard about in the last presentation. So NGC 2808. So this is actually one of the most massive globular clusters in the Milky Way. It's definitely universe scale age at 12.5 billion years old. It's got 3 generations of stars in it, which actually makes it a little less normal than other globular clusters. And it's got a tidal tail that is as the result of tidal influences by the Milky Way. We got index catalog 2602. So this is called the Theta Carinae Open Cluster. This is also nicknamed the Southern Pleiades because it's really quite similar. As you can see, it's a naked eye open cluster, and it's bright, and it's made up of hot blue stars. Excuse me. The Carina Nebula. So this thing is enormous. It's also called NGC 3372. It is one of the largest diffuse nebulas known. It surrounds several open star clusters and contains 2 of the most massive stars in the Milky Way. Excuse me. And this is a Hubble shot of that. Big. So we're talking about 120 by 120 arc minutes in size. Then there's Eta Carinae. And if you don't know the name of this one, you will certainly, I'm sure, recognize it when you see it. One of the most massive stars able to be studied in detail. It's a binary star system that in the 1800s started being noticed as being actually quite erratic as far as its brightness variability is concerned. And it started an eruption that expelled an estimated 10 to 45 solar masses of material, and it created a nebula around it. And that nebula is called the homunculus. This eruption, the light from this eruption reached Earth in 1837. The eruption lasted for 20 years, and it created two very striking lobes over time, and it actually conceals the star system itself, and that's what I'm talking about. The cool thing about this is when I was down in Chile during the 2019 solar eclipse down there, they I was on a mountaintop where Chilescope is, and there was a telescope there that didn't have a camera on it. I had eyepieces, and we stuck the eyepieces in it. It was a 24-inch RC telescope, so big aperture. Saw Saturn in it with like next to zero seeing, like sub-arc second seeing, and it just looked like a magazine centerfold, uh, an astronomy magazine centerfold. And he said, "Hey, you want to see one of the owners?" He was like, you want to see Eta Carina?" And I was like, "Oh yeah, I guess it is like in the skies here." And we slewed to it, and it was teeny tiny in the eyepiece, but you could see this, and it's just a remarkable sight and a remarkable structure. Now, having said that, is that about 180 years after the eruption started, light that was traveling in a different direction from us hit some gas that was in the area, and it basically reflected on the gas and dust. So what we're looking at here is actually a light echo. Okay? So it was a chance for scientists to study the explosion 180 years after we witnessed it the first time by studying the spectral characteristics of the reflection. So pretty cool. More about Constellation Carina, full listing of the 61 NGC and IC catalogs, deep sky objects. Go to this address right here at the Sky Live. More extensive description, you can go to Constellation Guide. The Annals, that's the Annals of the Deep Sky, Volume 4, covers Carina, and it is an absolutely amazing, in-depth coverage of Carina and talks a great deal about Eta Carinae and the Carina Nebula. And the last picture I wanted to feature is Stephen Kennedy's strikingly beautiful LDN 1519. It's dark nebula, and keep looking up. Thank you so much.
And you're up. You're up.
Thank you, Bruce. So, Treasurer's Report. Is that available? Yes, it is. Okay, so as you can see, our current balance as of January 5th is a little over $46,000. Income was primarily from members in the raffle, as well as donations.
We can't hear you on the Zoom call.
I understand we're working on it.
But it's not just me.
Can y'all hear me now?
Yes.
Yes, sir.
Okay.
Thank you.
Okay, so let's continue on. As I indicated, income was from members and raffle, as well as $850 in donations. Expenses of $37.79 includes a loan payment. And if you look at the bottom half, as you can see, a loan payment of $1,500 was made December the 10th. Our current balance for the Rising Star Fund is a little over $2,200. And as you can see further down, our loan has been reduced down to $7,380. Again, this report is also on Groups.io if you want to take a closer look. Any questions? Thank you. So we're going to pass on these. This is a draft of what we'll be talking about after the audit is finished. Yep. Keep going.
Very good. So this is the portion of the business meeting where I talk about the actions or the activities of the executive board. So let's go to the next slide. So the first item up has to do with the 2026 budget, where we said we like what we see, and the board approved it and sent it to this meeting for discussion, as we did earlier. So we're all done with that. Also at our January meeting, we planned for the internal examination that the club does on our, as you see there, the financial ledger and the balance sheet from the previous year. So we've got that already in work now, and we've got a team of 4 that are going to be working on that. And those people are Constantine, Robin, Chris Ashford, and Peter. Oh, it's Cy, and that's right. So we've got it. Okay, very good. We also approved a membership survey to be rolled out this month, and the details will be coming up a little bit later when Chris comes up. And then we also heard reports from directors about their conversations with the committee chairs. And so what we're trying to do is enhance the communication between the activities of the committee and the board. And so we've asked the directors, all 4 directors, to work with committees and other groups to find out what's going on, what are the challenges, what their successes are, and then bubble that up to the board. At least that's how I interpret it. Chris can fill in the details. All right. Then we also discussed some topics. One of the more important ones are the operating reserve fund. Constantine brought to our attention that the club may want to consider doing that, establishing an operating reserve fund. So he talked about the elements and the benefits of that. And I'll go into that in a little bit later. And then have we secured the location for the Young Astronomers program?
So we're looking at a new location. I was going to do a recon tonight, but it's too cloudy. But I'll do it tomorrow night when I come back from 1687. We're looking to start at the end, if this works out with the new venue, we're looking to start it at the end of February and give a class on lunar eclipse, because there's a lunar eclipse on March 3rd. And then we're looking to have it the weekend before Tandy Hills, so we're not conflicting with anything. But that's the plans for right now. We're still working through that.
Thank you. And then we're also considering procedures for adding topics to the board agenda. And then also at that meeting in January, we reviewed the RV and dog lease agreements that had been modified after the previous meeting. So work on that continues. Let's go to the next page. And that's the membership. Yeah, come on down. So ladies and gentlemen, Chris Ashford.
Thank you so much. So it's taken months to develop a survey. Anybody here who's been involved in surveys before in your companies or previous walks of life will know that it's extremely difficult to put a good survey together. So we've been working on this for 3 months. So we wanted to launch it right now, and in the board meeting, we will develop an improvement plan for the club. Things, technology changes, whatever ideas come out of the survey. So it'll come to you in your inbox using your Night Sky Network email, whatever email you registered with Night Sky Network, that's the email that's going to come to you. And it will come from my FortWorthAstro.com account, so that's directed to at FortWorthAstro.com. It's 20 questions. I'm asking that you fill in the survey by February the 1st, so that gets you all the way through that weekend. And then that gives the board time to sort of digest the material. Okay. Google Forms, if you haven't used Google Forms before, if you're not familiar with it, it automatically generates a whole bunch of metrics for you. So we don't have to manually do that. It just pops out at the end of the process. So we'll give feedback at the February general meeting. But the big thing is that on the board agenda, through 2026, we'll have an agenda item for an improvement plan. And, we made changes to the bylaws last year. For instance, we added an education special interest group, but that's as yet unpopulated. SCI is the Astronomical League point of contact for us. So I think next month he's going to talk about the Astronomical League and all the programs that they offer, for instance, or March. And so, once we gather all these things together, then we will create an improvement plan for the club. And it will be all your ideas coming to us, and we'll try to put it together for you. Okay, any questions? Thank you.
Thank you. Thank you, Chris. So question for the group. How many questions will be on the survey? 20. 20, yeah. And how long do you think it'll take to complete the survey?
An hour and a half. Well, okay, let me answer that. So some of the questions are optional. If you don't use social media, for instance, you don't have to answer those questions. Most questions, though, are sort of mandatory. How long it takes you depends. There are some open questions. What improvements would you like to see in the club? You can write a long paragraph, so that could take you, 15 minutes. Or you could just blast through the whole thing and get the whole thing done in 10 minutes. I don't know. So it really depends on you and how many ideas you have for things that you would like to see the club doing. So.
Again, thank you, Chris.
Pardon?
Oh, I'm sorry.
Is the survey anonymous?
The question is the survey anonymous? And you can choose. Section 1 is about you. And one of the questions is, well, what's your name? But it's an optional question. So you can be anonymous, or you can put your name up there. You choose. Somebody else had a question. Okay.
Okay, let's go to the next slide. So we mentioned the operating reserve fund, and we wanted to talk a little bit about that. Another phrase for optical reserve fund is a rainy day fund. We heard earlier that we have a considerable amount of cash in our checking account. And how many people here draw interest on their money in their checking account? Okay, 1, 2, maybe 3. So prudent shoppers, very good. We don't. And so we're looking at ways to establish a rainy day fund that we would identify how much money that we could put in a rainy day fund and then put it in a interest-bearing account of some kind. But what this does is it helps us weather an event that puts the club in a strap for cash. And so we could go to our rainy day fund and use that money to pay off something significant that came up. Or we could use it on a project that the group agrees to fund. It just depends on what we want to do. But we have to go through this process of figuring out what we want to do with the fund, how we want to manage it financially, and how much money to set aside. And so we're working through that, and there's a good chance that the board will review that once again and perhaps vote on establishing an operating reserve fund in the future. But these are the steps that you have to go through to figure out what's going on. We know what our operating costs are, and we know where the excess cash that we have, and we can figure out what monies we do need. We know how much money we spend throughout the year, and because we spend money in many months, we spend more money than we bring in. So it's nice to have the big influx of cash in the summertime when people renew their memberships. But we would always keep enough money to cover our debts in order to keep the club running. And then we would find a place to put this reserve fund, maybe an interest-bearing checking account, a savings account that pays interest, or some type of CD that would be probably around a 3-month CD. And then we would establish a policy on this, not necessarily for what we do this year, but it would establish a document that future treasurers and future boards could look at to say, oh, this is what we've done. And they could check themselves against that. And then we'd have to implement the fund. But these are some of the things that the board was doing, and we wanted to show you that we're going down this path. And we'll most likely be talking about it at our February meeting. Next slide.
Yeah, I think from the legal standpoint, last month we signed the agreement was 1687 for 2026, and they will still continue to pay us $1,500 for each star party we do out there, and we got our first one tomorrow night. Next slide.
Any other business for tonight? Okay, let's go on. Announcements. Let's move ahead. Oh yeah, Happy New Year. It's 2026. Let's keep going. Patrick. Anybody else that might have a outreach program to discuss? You might start making your way to the front of the room.
Okay, so that first one we're rescheduling that to next Saturday is we have a nice little winter storm coming, so whoever bought whatever, thank you. Let's see, the Monday one I've been informed that they're not going to be able to hold that, so that one's canceled, so don't worry about that. Next Tuesday we have one up in Springtown. It's a little bit further away. I'm going to help out with that. I've done it last year, good turnout on there. Then we got a science night on the Thursday. Next one. And Friday, this is the annual winter camp outs for kind of not a Boy Scout, but kind of a scout-like group there. So one of the people there actually has some private land just near Rome, Texas. Decent guys. I'll send out information on that a little later. And then February 3rd, Bell Manor, I think we actually did a solar, didn't we do them? Solar thing for them a year or so ago? So yeah, we've been there before, so we got that coming up. Then on the 7th, OS grade, that's another big one in Arlington, real popular one, annual one, so we have that coming up. And then on the 10th, going to be down in Glen Rose, so anybody in that area would like to help out, I'll be there for that. Again, I'll post these on the e-group, and any updates, if we have to cancel, I'll let you guys know. Thanks.
Thank you. Tandy Hills.
Well, for Tandy Hills, we didn't do very well last year. We had 5 out of the scheduled 9. So we're going to hope we're going to do a little bit better this year. Michelle, I think Tom said you had it in with God, or that God, something when you got your raffle ticket. So could you put a good word in for us so we could not be rained out every time? I do appreciate it. Our first star party, if it doesn't rain, is March the 21st. We're into daylight savings time at that time, so the sun sets at 7:41, and we will have Jupiter high and bright that night. So we'll talk about it before March anyway. I do have a schedule for 2026, and I will put that on the e-group and send that out to everyone.
Thank you, John. Pass. Yep.
This guy already said it. No, 1687, the first one is tomorrow. They called 2 days after they signed the document. So it just, to me, indicates the tremendous relationship we have with the 1687. And if weather is, if John would stop talking about the weather, we might do better. But they're a great group. We should have quite a few events this year, and it's worth at least one trip. Thanks.
Very good. Rising Star?
I don't think we got anything to report right now on Rising Star.
Those are actual pictures, people.
Oh.
And the night sky with the bells in the background.
So Bob, can you take it from here?
Probably be able to do light on if we can. We're trying to get my screen projected up.
I can do a quick one on this. At least on the Palo Pinto Mountain State Park, they're going to have a soft opening, they hope, late spring of 2026. That's what the rumor is.
We do have an annual meeting for the Partners Club. We have it every January. You can come. It's open. If you are a member of the Parks Partners, they usually do a hike after the meeting, and you can be taken on a guided hike through the park. It was scheduled for Saturday, but they have rescheduled it now for the following Saturday. That would be the 31st, and it's from 1 to 4. And it is at the park's headquarters or the pavilion. I don't know if they've really decided exactly where, but it'll be in the park. And once I get that information, I'll go ahead and pass that on so you can come in if you want.
You can do it here?
Yeah. It doesn't matter. Are you getting it? Why don't I just plug right into the projector? Okay, so while we're getting technology squared away here, what I'm going to demonstrate is where the website is right now. It's still a work in progress. I think it's pretty cool so far. But an update on the Noble. We had, Peter T. Arena and I worked over the weekend. We got we had an issue with the chains for the shutter. They were not the same length, so that's sorted out. The shutter operates very smooth and very quiet as compared to what it was beforehand. We have an issue with having the wrong kind of bolts holding up the rails, the C channels. So we have to order, I think about a dozen of them. And we're going to wait until it gets a little warmer before we go out there and turn into icicles to fix that. And then we have an issue with the dome synchronizing with the telescope. Before it was all over the place. Now it does start up synced, but after a while it becomes off by 180 degrees. Now you may think that's a big deal, but it's something that's consistent, whereas before it was all over the place. So I'm going to bring up the website here and try and get through this relatively quickly. Okay, so the website address is noic.fortworthastro.com, and it's live. So if you want to go experiment, knock yourself out, would appreciate feedback. It's updated all the time. And so what I'm going to talk about today is the registration process, target selection. We have 1,845 targets in our catalog right now, and it grows every day. And I'll walk you through what the image detail or the object detail screen looks like, and then how the framing wizard works. When we design this, the thought process is not for imagers like myself or Chris or Chris or Chris, but it's for visual folks. The idea is for folks like Michelle and Charles and Bruce to be able to pick something in the sky, frame it, and in a few clicks be imaging. So this is the login screen. So a couple things here. When you register, come on, there we go. Yeah, I can see that you can't see all the boxes and whatnot, but when you register, you will need the following pieces of information from your Night Sky Network account, because that's how we do the first bit of verification. You'll need your Night Sky Network user ID, your Night Sky Network primary email address, because you can have more than one, but it's your primary email address, and your Night Sky Network primary phone number. Okay, we're going to use that information and verify it against Night Sky Network. And I'm sorry? Your Night Sky Network user ID. So for example, mine is Robert _M _Circus. So, and if you don't have that information, you'll need to log on to Night Sky Network and get it. But we verify it. And your user ID on this system will be your Night Sky Network ID. Okay? So I've already registered, so I'm not going to go through the process. Chris, you registered, and Peter T. Arena did easy, not easy? Okay, thank you. All right, so when you log in, well, let me click. There we go. So again, you'll need your Night Sky Network ID. And you can click on the Remember Me box, but it'll only work for about 30 days. Okay? And then, so up here, you'll notice, and this will be displayed at all times in one shape, form, or another. This is the time at Rising Star. This is UTC time, and it's Rising Star local sidereal time. And eventually, there will be a red-green indicator that says whether the weather is safe or unsafe for imaging at the present time. And clearly, I don't know my password. I'm sorry? Pretty good security. Here we go. All right, so this is not the home screen. This is what I have right now. It helps me keep track of things that I'm thinking about. But generally, there's going to be a menu bar with options up here. So, but a couple things that will always be available. This is going out to Rising Star right now to get the weather. And this is something I just put together really quick. So this is, our weather station is up and online and reporting. The weather is unsafe because it's cloudy. And here's our temperature in Celsius. It's reported in Celsius because that's what Nina uses. Probably going to have an option that will allow you to do imperial or whatever the U.S. calls it. I can't remember. So, and there's a bit of information here. If it says NAN, which will change later, it just means that it's not available. And so this will, anyway, so that's weather. Then just to prove it up, we can go back and go to our famous weather station, and you'll notice that it's unsafe because it's cloudy, and we can look down here and see the clouds. So, although it's actually reasonably clear. Well, okay, so the way the weather station determines clouds is the difference between the ambient temperature at the surface and the sky temperature. And it's an IR infrared device that's sensing that. So we've been figuring that out. It's gotten a lot better, but we're still not quite there yet. I'm sorry?
You're right on the edge. There could be some clouds.
Oh, I'm sure there is, yeah, but it's reporting back that it's very cloudy, and it's not. So, okay. So, into the meat and potatoes. So, target search. So you'll come in and you'll do a target search, and this is going to bring up a list of objects. Now, I'm going to shorten this. You can set 10, 25, 50, and 100. So I'm going to just make it 10 for the moment to make this a little smaller. So on the bottom here, it'll tell you, showing 1 of 10 of 1,842 entries. You'll notice there's quite a bit of information here. So this first one was actually copied by Chris doing a test of the framing wizard. If they're owned by NOIC, that means that it's a starting point. You as a user won't be able to change the framing on them. But you get a thumbnail of the image, or of the object, and its key name, primary name, what constellation it's in, RA deck, what time it rises today, transit, maximum altitude, and set time. And these are all important because you won't be able to image anything that does not rise above 30 degrees. So the altitudes are color-coded. So if it's red, it's less than 40 degrees. If it's blue, it's 40 to, I think, 80 or 7. I don't know. Actually, I just don't remember. But so this can be helpful in determining what you may want to image. You can sort on any of these columns. So I can sort on name, or I can sort on RA if I want to. I can sort on maximum altitude. I can also sort on constellations. So we can come down here and pick Cephas, for example. And these are all the objects that we have for Cephas, and it tells us, yeah, 12 for Cephas. So we're also going to, there's one other box we're definitely going to add is for, not constellation, but catalogs. Okay, which will go somewhere around here. And then you'll be able to tick on My Objects, which will bring up a list of objects that you have created for yourself, and or all objects. Now this isn't working just quite yet. So let's say, and none of these objects are really very high, so let's go to, yeah, that's there. I'm looking at, I should be looking at my laptop. Okay, so let's say I'm just going to pick this guy. This is 48. So if I look at details, it takes a little time because it's doing some calculations on the back end. So what it does is it calculates, and when you guys look at this, if you think the colors are wrong or whatever, I need feedback, okay? Because I am not a GUI guy. So here we have in blue the altitude path of the object in question, okay? Here on the bottom in gold is the altitude path of the moon. And then we have a raw image, and then some details about the object here, what catalogs it's in, what type of object it might be. And these will be searchable later. And so from here, I can do one other. Let's just say for the sake of argument, I'm happy with this. I'm really not. So I can say imaging settings. Hit that, and you have drop downs to say how long you want to image, how many images you want, how many subs you want to take. We're going back and forth on whether or not to have like binning and some more complicated things that you may not necessarily need, or maybe, you know, if you're beginning this, you may not get it. So we're just, not get it, that's not the right phrase. The option may not be available to you. As you become more experienced, maybe we'll allow that. These are the kinds of things we're sorting out. And if it's your imaging time and you want to do a test exposure, you'll be able to do that. The RASA is a light bucket. So if you think you need 60 seconds, you probably need 30. So anyway, if it's your scheduled time, you'll be able to test some exposures. And we're going to take this information, we're going to look at it, examine it, and tell you if we think it's a good configuration for you. Okay, so the key thing is the framing wizard, and I want to find a better object than this.
So Bob, if, like, I've never done this, but if I want to like look at that, I put what I think might be proper time, and you guys look at it and say, no, you can do
We'll tell you right there.
Oh, okay.
Yeah. And you can, if you choose 60 and we think it should be 30 and you do 60, it does, yeah, it's whatever you want. Okay, so from here, and this is what I think is pretty cool. So we go to the framing wizard, and we're using HIPS data here. And let's say, well, you know, I really don't want it smack dab in the middle. I can just grab it, and I can move it over there. You can't rotate it because we have no way to rotate the camera. So from there, I click Save. I can give it a name. And if it exists, it won't let you overwrite it unless you tick it here to overwrite existing. So, okay, and it should take me back to here. So this is, well, minor bug. It should have captured the image that I selected in the framing wizard. So, it did. I'm just not picking it up. So, but you'll know the RA index. So if I want to move it, what I really wanted was that. So if I want to save it, I click Save. I'm going to override it. And so it's going to take me back to here. I don't know why it's not picking this up. I think I know what's going on. But anyway, what you selected will be here. You'll see that image here. And then from here, you can go and do your imaging settings and then move on to schedule. The schedule bit is going to be pretty straightforward. It'll bring up, I can show you, let's see here, I'll go back to list. Okay, I don't have that implemented here. It'll bring up a calendar. You'll be able to select your date and time that you want to image. And when you do that, we're going to look at what you want to image and make sure that it's actually going to be above 30 degrees on the day that you want to image and that kind of jazz. So, and make sure that you're not going to have a collision with somebody else. And it'll automatically do the imaging for you. Every day, if you have a scheduled event, you're imaging something, you get an email that says, by the way, your imaging session starts tonight at such and such, whatever the time is. You'll be able to come to the website. There is, let me go. So there'll be something about NINA status. So you'll be able to see what's actually going on during your imaging session. In addition, you'll see live stacking of your data. So you'll be able to go one place and see what's going on. And then when your sequence is complete, you'll get an email that says, here's the link to go get your data. And then you'll have a couple of days to get it before everybody in the club has access to it. So.
If you have a
Uh-huh.
tonight was cloudy. Does that just like go to the bottom of the queue, or
It's done. If you schedule, you know,
come to our world?
yeah,
So you're just out.
you're just out. You just have to reschedule. It doesn't automatically reshuffle.
Okay.
Yeah, so,
Bob, you should mention that the rise and set times are rising and setting at the 30-degree altitude threshold.
yeah, I said that already.
Yeah, that's an important point.
Yeah, so,
Anybody planning out there.
yeah, yeah.
Objects to the southern part of the sky,
Mm-hmm.
they never get to 30 degrees.
And you won't be able to image them,
Yeah,
basically.
yeah, if it's,
So you're out of luck on that.
well, if it's below the southern horizon, if it's below, we can only image stuff that's,
Well, it may not get 30 degrees above our horizon.
that's right.
Is that limit of the dome?
It's a limit of the trees, and it's a safety thing. So, yeah. Yeah, so on the south side, you have trees. And the other thing, too, is below 30 degrees, unless it's really a special case, your data's not going to be that good because you're fighting the atmosphere. So, yeah. So you would have to have absolutely perfect conditions for that. So there are some reasons. 30 degrees, I think, barely gets us above the southern trees. On the north side, it's not that big of a deal. On the west side, the trees that are right there, you know, they're, that big pecan tree in particular is, I think, about 32 or 33. And also, looking south at just about the 11 o'clock, you've got the power distribution unit there. So, trying to make it so everybody's successful. Are there any questions online, Chris? No. Okay, so this is where we are. I'll have another update at the next meeting, and as we get closer, we'll set up a U2 Zoom meeting and start having real-time sessions on how to use the website and how to image. Any questions? I'm trying to get us out of here.
Are you going to get a real SSL cert or continue to self-sign?
No, this is going to be a real website. So it's going to be it'll be secure. Chris was asking him.
It's a self-signed SSL cert right now.
So this is a development environment, and most likely this is going to be hosted by AWS. So I'm not worried about it. Okay, I think that's it. Oh, please do, if you have suggestions for layout of this or whatever, send me an email.
Are we going to have the ability to remote desktop in and use
No.
SharpCap at all?
No.
Okay.
No. It was about remote desktop. No, the only access to the general population, general membership will be through this website. So, and I know you're talking about EAA, but we have a way to do that without SharpCap. So, any other questions? Thank you very much.
All right, so look at the time. We're over, so I'm just going to ask for a motion to conclude our meeting. I know. And we have a motion, second? All right, so let's raise hands to close the meeting. Very good. Thank you for your time, and we'll see you next month.